You may be wondering, first and foremost, who is that ponytail guy that's standing up there on stage? My name is Greg Shields. I am an MVP, a vExpert, and a CTP. I'm also a senior partner with a company called Concentrated Technology. If you've ever read a white paper or attended a webinar for pretty much many of the vendors that are out there in the IT space, at some point or another, you've probably read something that I've written or presented at. I've been doing this for over 15 years now, across consulting and speaking and writing, and even a columnist for a couple of different magazines. I just actually got here from a completely different conference in Seattle last week, in fact, 2 days ago, long enough time to fly from Seattle back home to Denver, kiss my wife, and then fly here. So you know how all that goes, right? Y'all are probably here because you want to see more about VMware. You want to know what's going on in the world. You want to know what are the right decisions to make in your own environment. A couple of things lately, just a little freebies you want to take a look at. Number one here is a new book sponsored by VMware at realtimepublishers.com. I just finished writing this book. I've written 15 books. I give them all away for free. So right there, new best practices in virtual and cloud management, sponsored by VMware. Also, if you're looking for some training, I've got a couple of new training classes coming out from CBT Nuggets, one on vSphere and one on VMware View. We're here today because we've got these environments, right? We're somewhat virtualized. We're kind of virtualized. We're trying to figure out what is the best thing to do to support the needs of our environment. And so consequently, we come to these events, number one, because, well, there's free beer almost all the time. And number two, because, well, we got to figure out what to do and then prove that we actually learned something when we go back. So what I've done over the next 60 minutes is I've tried to kind of consolidate over a large number of consulting engagements a lot of the different sort of problems that one sees when one steps into a brand new environment. Right? You have been in your environment now for some period of time. You come in every day, you have your coffee, you sit down, you look at those settings, and after a period of time, they all just sort of get in the way, and you forget about all kinds of the settings that you may have set a long time ago. You know, back to the Windows world, we did this with Active Directory. When was the last time you touched Active Directory sites and services? Not that long ago. When was the last time you actually touched any of the configuration settings in your HA or DRS cluster? Might have been a while also. But what's neat about being a consultant is that you can actually walk into a person's environment with a fresh pair of eyes and come to understand, well, wait a minute, something doesn't smell right here because I'm looking at this not having had looked at it every single day of the week for the last umpty million years. Now, we have to have, before we even get to that point, we have to have just a couple of reality moments first, right? Y'all know what HA and DRS is, right? Does anybody here not know what HA and DRS is? Okay, see me after class if you don't want to raise your hand. In reality, though, HA and DRS are designed to solve two really specific problems. Right? In the HA sense, HA is there to, they gave me a really cool green laser, which is far more powerful. In the HA sense, actually it's less powerful, doesn't work. It's there to protect us against unplanned host downtime. Right? We end up having some sort of host that fails. And HA, it's HA's job to then reboot those machines somewhere else in the environment. Right? You know this. This is sort of basic, but a couple of you don't. So this is why I've got to start here. Now, HA is there for these unplanned host downtime events, but honestly, these days, how often do those things happen? Well, once in a while. But our hardware is becoming so redundant that, well, you know, HA is there for those occasional situations where hardware has a problem. Now, contrast this with DRS, where DRS's job is actually twofold. And I just actually updated this slide because I just recently realized the second half of what DRS's job is. It's there for load balancing of virtual machines, but it's also there for defragmentation of the resources that exist on your hosts. So DRS kind of plays two roles. Number one, to make sure that you've got the right VMs on the right servers, but also that you've got the right collection of those resources to support all of your future needs as well. Does this make sense? This is like the 100 level, right? Now, supporting both of these is this notion of vMotion. Has anybody here heard of this technology called vMotion? Okay, you have. Let me just demo it for you here really quick. No, I'm kidding. You just click a couple of buttons and there you go. vMotion is not terribly exciting. But you remember a day, though. You remember a day when vMotion was exciting, don't you? You remember coming into events like this and someone says, check it out. Watch this. I'm going to vMotion this VM over to that host, and nothing happened. Right? Check it out. It didn't even lose a ping packet. Well, vMotion used to be this really sexy, feature in vSphere that these days, well, you want to laugh at me if I want to try to show you a demo. vMotion is the enabler for a lot of the things that I'm about to talk about here in this session. But what's important, even if vMotion itself isn't terribly exciting, right? What is exciting is recognizing where those bad HA and DRS settings can impact vMotion's abilities to do its job. So when you go and look at different environments, whether they be large or all the way down to the very small, you'll find that a surprising number of environments have configured the settings incorrectly. Now, some of them do because of various hardware constraints. And when I say hardware constraints, I mean you didn't have enough money. We've all been there, right? Does anybody have an unlimited budget? Here. In the back. I'll get you my business card. I have very inexpensive consulting rates. Now, others, however, have not designed their architecture with HA and DRS in mind. We all started, remember back in the early days, we started with a couple of ESX hosts, but we might not have actually designed these feature sets when we first conceived our whole virtual environment. Others have actually introduced problems as their environments have scaled upwards. So as you've gone from 2 to 3 to 18 different hosts in your cluster, you might not have realized that there are a number of settings that you have to pay careful attention to, or you're going to create some real big problems. So this actually is, as I mentioned, kind of the second presentation of this. Last year we had, I think, 2,200 people show up to this event. And so I said, why don't we actually go ahead and do this session again? But I want to spend the time to augment last year's 16 mistakes with a new 19 big mistakes that you'll want to avoid as you build or scale your HA or DRS cluster. If you run out of this room screaming, we'll know that you're making a phone call to go make a change right now. So, are you guys ready? Are you ready? All right, let's do this. Because my friends have the photo, you were excited. And some of these, they may sound kind of basic to you, but remember there are people in the room next to you. So, number one is, in fact, and this happens more often than I care to admit, or perhaps even you care to admit. Big mistake number one is just simply not planning for the evolution of hardware over time. Now, most of us realize that we can't just go creating clusters out of some Intel and some AMD, right? Because you just really can't vMotion between Intel and AMD without a bunch of really not supported extra settings. Well, what a lot of people sometimes forget, especially as they get to the whole purchasing process, is that the processors actually need to be of proximate families if they're going to be able to be vMotion, or VMs are going to be able to vMotion from one host to another. This is not a problem today. This is a problem 3 years down the road when you finally get some budget again. I just copied this, actually, this cluster baseline directly from VMware's website, literally like 3 days ago. And so it shows you that, for example, the AMD Opteron 1XX does not vMotion with the Opteron Generation 2. Now, this, and actually here on the Intel side, the screen is much bigger. Exactly. Now, what's interesting here is that the hard part is really planning for these in your whole delivery system. How do you go about purchasing the right equipment so that you don't end up in a situation where you have, a cluster of hosts that can't vMotion against each other? The problem is that as that hardware environment ages, the hardware gets refreshed and new hardware gets added. And so those refreshes sort of artificially create these islands, as it were, of vMotion compatibility. Sort of begs a question then. How can you always ensure that you can always vMotion between the computers in your environment? Always refresh all the hardware at the same time. That's why the Expo exists here. You can cold migrate, right? Because cold migrations always work, but they're not very friendly. Well, the third technology down here that surprisingly a number of environments have not even turned on is vMotion Enhanced Compatibility Mode. Now, who here's turned this on in their environment? Looks like about half of you. The other half, take a look at EVC. Now, EVC is interesting because what it does is allow you to create these islands as clusters. This is a screenshot of it. Actually, now a fairly aged screenshot of it. And what it effectively does is it kind of dumbs down the processors so that certain instruction sets that are maybe only available on certain cluster hosts are not going to be made available for the cluster. Now, you turn this on, it definitely increases the compatibility between the different hosts that exist in your environment. And without this, you can actually end up with a situation where you might have a cluster of hosts that can't have vMotion going across those different hosts. And that's bad, because the decisions made by HA and DRS may be based off of the fact that all these machines can have vMotion to occur between them. So EVC, an excellent, very important technology to turn on, and particularly now in 5, and also with the upcoming in 5.1, it's something that there's not a lot of downtime associated with turning it on. Does this make sense? Number 2 is when we're looking at vMotion. Well, the 5.1 release has some pretty cool technologies in the S vMotion. But we also have to plan for actually making available enough resources to support SVMotion, right? If we have virtual machines with snapshots, those snapshots can't be SVMotion. Any of you here have virtual machines with long-running snapshots? No? A few of you. I have very inexpensive consulting rates for those of you that do when you go to roll those snapshots back. Anybody here actually had a snapshot rollback incident cause a resume producing event? A few of us, nobody's raising their hand on that one, right? Disks must be in persistent mode, or RDMs. The host actually must have sufficient resources to support 2 instances of the VM running concurrently for a brief time. Now, that seems like not a lot. But you'd be surprised, particularly in the small environments, how close to 100% utilization that some of these environments end up getting to. You also have to have a license. You have to be correctly configured for vMotion. And you have to have host access to both the source and target data stores in order for this to work. So really, when you're focusing on protecting yourself with vMotion, you're going to make a lot of the same decisions that you do with SVMotion. And that only gets even more important as we start moving into 5.1 with all the new technologies that you found out about here and what you'll be implementing here in the short to medium term future. So these are kind of vMotion-centric sort of problems. These are the problems we have to be conscious of. But one of the big problems that you see whenever you run around and go to all kinds of different environments is just simply not speccing out enough hosts for the cluster. Who here has a small cluster? Who's got a small environment? A couple of you? Raise them high. I'm a small environment. Show pride. It's okay to be small environment. Welcome, friends. You know, small environments have a lot of problems, right? What's the biggest problem in a small environment? Money. Right? You can't really just go out and buy an entire pod of equipment. You can't go buy all kinds of equipment necessarily to, just to have excess laying around on hand. But what a lot of people forget when they create these clusters is that there actually is a need for additional cluster resources that actually don't get used. Right? You've heard of the concept of cluster reserve? Cluster reserve are these resources that need to get set aside should HA need to actually fail over a virtual machine. Well, the politically correct term is cluster reserve. I think the rest of us like to call it waste. Well, waste is important, actually, because, as I said, many environments don't actually include the resources that are necessary to support cluster waste or cluster reserve in their configuration. So if I'm one of those environments, and I have, for example, here, I have 3 hosts that are sitting at 100%, and or all 4 hosts that are sitting at 100%, and I lose this host, what happens? it's a really bad day, right? If I don't have these resources to support this host, well, there's no place for those virtual machines to go without creating some very downstream problems. So a correctly configured host is not only one that can support all the virtual machines, but also a cluster that can support the failure of at least one full server's worth of resources. One server that just sits there as waste. What do you think of that? I don't like that very much. It's tough whenever, you're trying to, I really need 3 servers, boss, because I want to go this virtualization route, and oh, by the way, I need one server that just really does nothing. That's tough to do. Well, VMware actually makes that available for you if you turn on your admission control policy whenever you're creating your cluster. Right here, under admission control, you have the ability to turn on or turn off whether or not it enforces that extra waste to support the needs of those failing virtual machines. And this is really important. If you don't turn this thing on, you're going to end up having that situation where you compress resources in an HA event, and that creates a bad day. Now, when you actually do turn it on, you've all seen this because we've all created a cluster at this point, at some point, right? When you do turn this on, you actually then have to set a policy for determining how the cluster is going to behave. This is the policy here, right here. And let me ask you a question here. So host failures cluster tolerates. Is that not the worst named policy in the history of all IT? Host failures cluster tolerates. In fact, you might not know this. This is actually a screenshot back from the 4.x version of vSphere. And one of the new features in version 5 is they added the word "the" there. Host failures the cluster tolerates, which suddenly makes more sense this way, right? What does host failures cluster tolerates mean? What does host failures the cluster tolerates mean? It's how many hosts the cluster is going to tolerate to be down before the cluster just gives up and goes home. That's what this is for. In fact, setting host failures cluster tolerates to 1 ensures that no matter how many machines you may put into your cluster, you will always have at least one host's worth of resources available in the event of a failover. Does this make sense? Well, good. Because if this is big mistake number 3, then big mistake number 4 is setting host failures cluster tolerates to 1. We all have a cache problem, right? And if I've got a 3-node cluster and I have to buy a 4th node for no other reason than just to provide empty space for all the virtual machines in this environment, that's kind of a hard sell, isn't it? Somebody else said they were small environment. Is that a hard sell in a small environment? Who's here in a large environment? Is that a hard sell in a large environment? No. Who said no? So setting host failures cluster tolerates to 1 is going to set aside one host's worth of resources. But there is actually another setting that you can select that can be a little bit better for you, I guess. Now, VMware doesn't want me to show you this slide. But this slide here talks about the second of these 2 settings. Now, again, this is back from a previous screenshot. With a version 5 now, we can split it up by CPU and memory. But I like this screenshot because what it does is highlight what the equivalent of host failure cluster tolerates equals 1 is. So right here, I've set the percentage of cluster resources reserved as failover spare capacity to 25%. If I have 4 hosts, and I want to set aside one host's worth of resources, what percentage is that? All right, so let's try. So if I have 7 hosts, how many, if I want to set aside 1, what's that? I was just seeing if you were awake. That was a little math for the afternoon. So you want to actually set this, if you end up selecting the other radio button, the goal here is to actually set a percentage of cluster resources that are at a lower value than one server's contribution. Why would I want to do that? Why would I do that? I mean, are all the VMs in your environment tier 1? I mean, you've got a lot of VMs that you don't care about, right? If your, I don't know, if your config manager server dies, you don't care. If the, I don't know, the email server for the marketing department dies, you don't care. Like, these are things you don't care about. And so you can, if you have a host failure, and you don't really care about certain machines, well then, if they don't fail over, that gives you some time to actually fix the cluster and get things back online again. But what we see whenever we walk into environments that actually do this is that big mistake number 5 is those environments then forget to actually prioritize VM restart. This is one of those settings that you ignored when you created your first cluster. Right? You created that cluster, you went, I have no idea what this is, and moved on. It's okay, because all of us did. But what VM restart, or the VM restart policy, is a setting that when that failure actually happens, it will actually let you, or identify which of the VMs are going to restart first. These become important, as you can see here, during an HA event, specifically when that percentage policy gets enabled. There's like a high, medium, and a low. I think it's medium by default. I tend to set mine to low, so I have 2 tiers that I can do between high, medium, and low. Now, what's interesting, and this is the Easter egg that not a lot of people actually know, is down here at the bottom, that restart policy is not global. Did you know this? The restart policy is per host. And so when HA decides to move things around, and the restart policy actually invokes which machines get restarted, is going to depend on where they actually end up getting located. That can be somewhat of an issue if you're not careful, again, with that VM restart. And also, there are some situations, too, where you can have virtual machines that power on in the wrong order. Because the determination of when we move from the high machines to the medium machines to the low machines is not the successful completion of the reboot, but that that vCenter is actually heard, or that the HA service has actually received the, yes, I am now attempting the reboot. So there can be some situations, if you have virtual machines that don't power on in the right order, that sometimes this doesn't work out very well. Pay very careful attention to this because, well, it can actually create a pretty big problem downstream. Now, many of us take a look at a lot of these settings and go, really, this is just, I really just don't want to deal with this because, well, I can't pay for this. I can't afford having to deal with all this waste. And so consequently, it happens more often than not that when, I mean, we're IT people, right? When we see an error message, what do? We turn whatever that error message is off, right? It says I can't turn on another virtual machine. Well, screw that. I'm disabling emission control. Check it out. Well, when you walk around in these environments, you see more often than not that some enterprising, supposedly brilliant IT pro goes, hey, check it out. If I turn this off, I don't get the error messages. So many of us have tried to turn it off and forgotten about it. Turning it back on becomes a challenge because we can no longer meet the reservation requirements of that cluster. So big mistake number 6 sounds sort of silly, but never disable admission control because it will create some big, big problems, especially as hosts begin swapping from those post-HA events. Doesn't make sense. It should. So, all right, I know that I should leave admission control alone. I know that host failures cluster tolerates is maybe a good idea, but maybe not. Maybe I have some of those VMs that I just don't really care about. So I turn on the percentage policy. And then I go off and do whatever it is I do for the rest of my career. You move on. We do different things. One of the big problems, however, is that percentage policy is a very static number, is it not? If I have 4 machines today and 7 machines tomorrow, I keep putting up 8 fingers, 7 machines tomorrow, well, oh, that's right, 4 and 3. I can't add today. I've got to actually go and update that percentage policy as I add new hosts into the cluster. And so, okay, maybe some of these are fairly simple, but big mistake number 7 here is one we see all the time. Because as the cluster size grows over time, we forget that cluster percentage actually requires adjustment. if I go from 4 hosts to 7 hosts, then I want to have the same percentage of protection. I got to set that thing back down. Okay? This should make sense. And if there's anything, this is one of the ones that should have you running out of the room screaming right now, because you might not actually have the level of protection that you think you have in your environment today. Now, what's interesting is that the host failure cluster tolerates setting down here actually doesn't need adjusting. Right? No matter how many hosts you have, that policy setting is always going to set aside 1 server's worth of resources. So, okay, Greg, you've told me don't put it to host failures cluster tolerates. And you've said, well, actually, don't put it to the percentage resources. Well, wait a minute. There's some real big problems here. Let me ask you a question. So, we all get money from time to time, right? You get a budget, and when you get that budget, you might get a little excited. You know, personally, at least for me, one of the most fun tasks of being an IT pro was spending somebody else's money in a large quantity, right? So one day you get, I don't know, your boss gives you $250,000 or $100,000 and says, you know what, go buy some servers. What do? You buy big ones? You buy small ones? What do you prefer? What do you prefer? Do you like the big ones or the small ones? Big ones? Anybody else here like big servers? I like big servers. I mean, they're big. But you have to be careful with big, especially in this cluster world. And specifically, you have to be careful with buying big occasionally. And there's another part to this whole host failures cluster tolerates situation. And it has to do with how it calculates all the slot sizes and all of that magic that goes on underneath the covers. When I have a policy that sets aside the amount of resources that are needed to protect any server in the cluster, well, then any server in the cluster can also mean our biggest server in the cluster. So if I have a cluster of 3 hosts, and I have 4 hosts, and I have 1 host that is exceptionally large, and I use this host failure cluster tolerates configuration, what is it setting aside? The entirety of that very large host. And so now you've just wasted even more money. So don't do that. Buying the occasional big, if you're using this policy, can actually create a problem. So in the back and forth between which should you choose, make the right selection, which is for you, but make sure you're also paying attention to the downstream effects there. Number 9. Has anybody ever had a problem with host isolation response? Who here has had a host isolation response issue? If you could describe that in one word, what would it be? This is a PG-rated conference, a family. We're all family. Shoot. Yeah, it sucks. How's that? It's not a pleasant day. What is a host isolation response? What is that? What happened? One of the hosts got isolated, right? Poor guy. Its management network died. Its VMs may or may not still be running. And now, because it's been isolated from the rest of the cluster, well, we have to make decisions about what we need to do, right? This is another one of those settings that when you built your cluster, you probably ignored until the problem happened, and then you fixed it. Now, host isolation response, one of the reasons why you ignored it is simply because, well, it's a very challenging, it's a very hard to understand term. I don't understand why they chose that term. It's just very difficult for someone that's never seen that before to really understand what it means. It also has 3 settings, 2 of which create pain for we IT professionals, right? When something goes wrong, immediately shut down the virtual machine. We go, no, that's bad data center management. But for a long time, VMware actually suggested shutdown as the correct response if you should end up in a host isolation situation. You know why? One of the big reasons was for fear of splitting the cluster, of having that kind of split-brain situation. And if the VM actually stayed powered on, well, either half of the cluster might actually try to restart that VM thinking it wasn't running on the other side. So shutting down the VM would release any of those VMFS locks on that VM, which could prevent them from being evacuated out to a good host. Shutdown actually gracefully shuts down that VM. It releases those locks and allows the surviving nodes, the master of that cluster, to actually see, hey, check it out, this VM's down. It's been shut down correctly. I can reassign it off to a surviving host, and everything works again. Well, VMware has had an interesting dance between should we go shut down or leave powered on, and they've actually changed the policy, their recommendation, 3 times now. Between 4, sometime after 4, and then 5, and I think now again. And now the current recommendation is for you to set this to leave powered on in all but one situation. Can you tell me what that situation is? It's on the slide. How many people here have converged networks? You know, where you've got the management network is on the same network or NICs as the VM network? It's okay, we do this because it makes things easy, right? But if I end up with a host isolation response situation, what am I doing? I've lost that management network, which means I've also lost the VM network, which means that the VMs can't connect to storage, which means the VMs are now sitting there going, I'm queuing all of my storage I/O, waiting for storage to come back. So in that situation, you really don't want to shut those things down because of how they end up being, you could end up creating some downstream problems. For the rest of us that have had our management networks and our VM networks actually separated, well, it's okay to leave them powered on. There's some new logic built into HA that actually supports not having this 2 copies of the VM running at the same time. And so leaving it powered on is actually the best practice, except when you have those 2 networks connected. Really, at the end of the day, when you first make that management network connection, you get that little dialog box that says, hey, I couldn't help but notice that you don't have any management network redundancy on this connection. The best idea is to pay attention to that dialog box, because it means it. For those of you that have a host isolation response, what did you do? We call the network guy. What did the network guy say? So it was his fault. Yeah, this network guys don't know anything, do they? It's all virtual these days. Anybody here a network guy? Okay, see me after class. So, all right, so in version 5, right? In version 5, we got this new technology, this vast power of heartbeat data stores. Anybody here on 5? Actually, a curious question. Who here is on 5? Oh, good. So have you implemented your heartbeat data stores? Yes, because it just implements itself, more or less. Now, in 5.x, vSphereHA can use the storage subsystem as a secondary communication path, which means that if I end up with my management network actually getting disconnected, well, then I can use the storage connection as a path for the HA master to then figure out what's going on in one of these isolation incidents. It adds redundancy. It's only really used whenever the management network is lost, such as in the case of isolation, or when I've got a cluster that's been partitioned. But big mistake number 10 is getting a little bit excited about a technology like heartbeat data stores and assuming that heartbeat data stores actually prevent isolation from occurring. This is something that is commonly misunderstood. The data store heartbeat is used by the master to determine the state of an unresponsive host. It enables that HA master to determine whether or not the host has failed completely, and there's all sorts of magic that people that have black on their name badges will tell you about later, of how that works. But that magic identifies whether or not it's failed completely or if it's been isolated, meaning that the virtual machines are still running. Having that heartbeat data store, however, does not actually prevent an isolation event because the response that you've coded into your cluster is initiated by the isolated thing, right? The machine that actually gets isolated. It says the slave here, but more specifically, it's the machine that actually gets isolated. All right, so let's say we have a slave, for example. When that slave gets isolated, poor guy, it enters an election state because it sees, well, check it out, I'm the only person in the universe. it enters the election state. The slave elects itself as master, which I just love that line. That's directly from VMware's. If only the rest of the world were like that. The student has become the master. The slave then pings the isolation address, which is an address that you configure in with the cluster. And then the slave declares itself isolated and triggers the isolation response. So this takes about 30 or 40 seconds or so for this to occur here in version 5. And that isolation response, if it's set to shut down, it's going to shut it down. So when I told you leave powered on could be a good thing, well, that can be the case because maybe you need to talk to your network person who screwed up, and they just need to replug back in the cable that they tripped over, and problem solved. So again, make these decisions based off of your own environment and really what makes sense to you. Number 11 here is one, compliments to Duncan Epping, actually, who provided this for me because I didn't even know that I probably made this mistake myself. But he recommended this as one that needs to be told to people. So APD and PDL are, two TLAs. The first of which corresponds to an all points down scenario. Right? That scenario exists whenever all the communication is severed between the host and its device, typically its storage device. Now, when that happens, it's really a bad day, right? Your virtual machine I/O then gets queued at the host, and it can actually get queued indefinitely as the host is waiting for some SCSI-based response code that says, hey, you know what, that link is actually down, and it's down for good. Now, the APD scenario is not supported by HA. If you have an APD scenario, if you have a situation where you've just yanked out the cable, either logically or physically, between your storage and your virtual machine, you can end up with some real bad situation on the part of the virtual machine. Now, built into 5.0 Update 1 and again in 5.1, there's been some improvements to the other scenario here called the permanent device loss. Right? Sometimes, it's like the bad girlfriend. Give up, she ain't coming back. Right? The device has been removed from the environment. It's not coming back. It's some DVD, for example, that's not coming back. It's some piece of storage that you've removed specifically, and so you want the environment to recognize that this is a permanent device lost. Well, in a PDL scenario, the machine can see the device target, but the device target just simply isn't listening. The storage isn't listening. Now, as I said before, APD is not supported and will not trigger a vSphereHA environment. The VM will continue to run. It's not going to be able to read and write to its disks. But now in V5 U1, HA can now take an action if instead you've actually achieved a PDL state, where you've actually removed something purposefully. And so there are two settings here. Don't write them down. You can get them from the website later. But these two settings will allow you to, number one, ensure that VMs are killed when their data store reaches that PDL state. Right? We set that terminate VM on PDL default to true in etc VMware settings. And then the second one down here, we set to true to trigger a restart response when any VM then gets killed because of the PDL situation. So those two can be very handy for situations when you have that or for those situations when you have that experience. Now, where this comes in handy most often is if you've actually created these newer stretch cluster and metro cluster configurations that have been getting a lot of attention lately, honestly. Where we have a cluster that is still a single contiguous cluster, but maybe separated by a short geographic boundary. So thanks, Duncan, for number 11, if you're in here. Or if you're not, or on the video, hi. Number 12. We spent some time here talking about, all right, all these different things that are associated with HA. And we have to also spend a minute kind of talking about the resources. Before we really understand load balancing and how DRS can do this resource defragmentation, well, we have to spend a minute really kind of focusing in on how we might set up all of these resources. And big mistake number 12 here references a problem that we created, or that we are creating. It's one of those situations that anybody here in the Microsoft world get your MCSE way back in the day? Remember that? Remember all those buttons inside of Active Directory that you would click? that you would never click these days? It's kind of the same way here with reservations, shares, and limits. Now, a lot of these are configurations that you might think would be a good idea to set, but can actually, have some very downstream effects that are really hard to understand and can impact DRS's ability to do its job. The first and foremost is when you create soft affinities like limits and reservations and shares, HA in an HA event goes, oh goodness, we've got to get stuff moved over. And so when the initial move over happens, it may not actually even consider these soft affinities at first. Once it's got everything moved over, then they can be invoked afterwards to ensure that HA can do the corrective action. Now, reservations and limits have a tendency to constrain these calculations from actually happening. You think about it, right? If I set a reservation and an HA event happens, and I need to move a virtual machine over to another host, well, I could have a potentially very large reservation for that machine, which can impact the different positions of different hosts it could potentially be moved to. Affinities add even more constraints, particularly in smaller clusters. So when you are using reservations, limits, affinities, these sorts of things, be very careful. They can actually, be very careful in using them really at all, because they can actually create some pretty significant problems, particularly whenever they're associated directly onto the virtual machine. Makes sense, right? So reservations are maybe not so good, and limits are not so good. Well, maybe I think about using shares, right? Shares are nice. Shares can balance those resource demands. I don't have to set a hard threshold. Maybe they have a much better or much lower impact on DRS, and so therefore, consequently, also HA. So maybe shares could be a good thing if I implement them correctly. But as you can probably imagine, there's a big problem here that could happen if you don't consider using shares without actually considering using shares. You got to spend some really, really careful time with how you actually use these. And one of the nice things and one of the really challenging thing about shares is the top bullet up there. The fact that shares are only considered when you're actually in a situation involving contention of resources. That's important. Shares are only considered when you're dealing with resource contention. And that's very different from limits and reservations. A limit always holds, a reservation always holds, but a share only exists when I'm seeing that contention. In fact, shares have another really insidious problem. When I use shares on resource pools, I can actually have some real unexpected results if I don't do things correctly. Here are two quotes from pubs.vmware.com. And it's associated with the use of shares just inside of a cluster. The first one reads, when you assign shares to a VM, so directly onto a virtual machine, you always specify the priority for that virtual machine relative to the other powered-on virtual machines. Does this make sense? If I set a share for a virtual machine, that share can prioritize that VM in comparison with the other virtual machines on the host. Now, if I set a share on a resource pool, and here's where things get really weird, sibling resource pools share resources according to their relative share values. Repeat after me. Sibling resource pools share resources according to their relative share values. Amen. Why is this important? Because how many of you have done this? Raise your hand if you've done this. I've created a couple of resource pools. I've created one for me and one for everyone else. Because I'm the IT guy, or girl, so you know what? I'm going to do that. And so these resource pools, a lot of us, or not a lot of us, some of us treat resource pools almost like folders. You do this? You create like okay, I got a resource pool for marketing and everyone else. Ha 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 ha. And then I can assign shares to them. Well, I told you that this problem was kind of good, and it was also kind of insidious. Because shares only come into account whenever we have contention. And so when I create this environment, and then at some point 50 years down the road, I actually get contention in the environment, what actually happens looks like this. The 4 VMs in my test resource pool, which have 1/5 of the total resources, share that 1/5 just fine. And the 50 VMs in the right resource pool, and they have 4/5 of the total resources, are suddenly fighting for all of those resources that are left. So, repeat after me again. No, I'm kidding. Just be careful with shares whenever you're associating them with resource pools. As I said back here, when you assign those shares to a VM, it's that VM in comparison with the other VMs on the host, which is far, far different than how we end up with the shares circumstance here when I associate with them with resource pools. Now, all right, so shares are bad, right? Well, all right, I'll use limits. Limits are good, right? Limits protect me from a virtual machine doing too much, like SQL, right? Everybody knows the SQL problem, where it will eat up every bit of memory that you give it. Have you tried this? Right? Okay, so I'm going to give the SQL VM 4 gigs of memory, and then I'm going to be really smart and put a limit on it of 1 gig of RAM, right? Have you done this? Don't raise your hand. Because if you have, you've created a problem. What problem have you created? I've created a hard limit. So the VM goes, hey, check it out, I got 4 gigs. And when the VM attempts to use more than its allotted limit of 1 gig, all of that extra RAM has to come from one of 2 places. And neither of them are very good. Swap, ballooning. So you never want to assign memory limits, really, because that can, especially if they end up being less than the actual assigned amount of memory for that VM. In fact, it's just a good practice to limit memory or to limit any sort of resource as close to the affected application as possible. This is just good best practice. If you can limit a resource like memory at the SQL level, that's better than doing it at the Windows level, which is better than doing it at the VM, which is better than doing it at the hypervisor level. So always try to limit those resources as high up in the stack as possible. Now, number 15 here is, I put this in because of an old buddy of mine who made a bet that he'd lost, who he thought he was actually smarter than DRS. He said, I got this thing set at partially automated, I think it was manual, because, you know what, I'm better at figuring out where all these different resources go than some sort of, math, right? Well, math is smarter than you, which is important. He actually lost the bet. We turned it fully automated, went to lunch, came back, and everything was at a different place. But if you haven't actually flipped things over to fully automated because you're just one of those people that's, you're a control freak, you might do that. My wife says I'm a control freak, but I choose fully automated. Before you do, you really need to understand deeply what DRS is doing whenever it's actually doing the equations it's doing inside of itself. That was a completely bad sentence. When DRS is doing things, it's kind of like one of those bar tables. Anybody here ever been to a bar? Right? We're at VMworld, right? We've all been to a bar. Right? You know the high-top tables. They're round, and they got a post in the middle, right? Well, DRS is kind of like one of those tables. And each of the sides of the table corresponds with, well, one of the hosts in that cluster, right? And as a cluster host starts to get a little hot, there's more stuff going on. Maybe somebody sent a dirty email or something, and so the Exchange server is getting a little hot. What does it do? Well, it moves that Exchange server over so the table, comes back in alignment again. And so DRS's job is like that spinning top or like that high top table at the bar. As the amount of resources being consumed on a host starts to get further away from everything else, well, it does activities in order to get that table back into balance again. That's what it's there. When we talk about load balancing, think about the bar. So how does it work? Every 5 minutes, a DRS interval is invoked. And during that interval, DRS analyzes the resource utilization on each of the hosts on that table. It plugs those counters into the equation, the summation of the entitlements divided by the total host capacity. Those entitlements are the CPU resource demand, the memory working set, Also, any reservations or limits which are going to impact these calculations. The host capacity down at the bottom is the summation of the CPU and memory resources minus some overheads, VM kernel, service console, minus any reservations for admission control, and then also a small percentage extra reservation. So it's actually using its monitors to calculate what is going on each of the hosts. Now, I know I promised you there would be no math, but hold on for just a second, because I need to talk to you about a mean and a standard deviation. Everybody here know what a mean is, right? It's an average. Well, a standard deviation is an average deviation from that mean. I know this is getting hard here. Does this make sense? Right? It's how out of balance are things. That's what a standard deviation is in this sense. So if you've ever actually looked at your DRS settings and saw that setting called current host load standard deviation, that's actually what we're looking at here. The current host load standard deviation is the current how out of wobbly, or how wobbly is this table currently, right? Am I out of wobble? When I then create or attach the cluster, and I set that slider back and forth between 1 and 5, or conservative and aggressive, what I'm doing is changing the target host load standard deviation. So effectively, what I'm trying to do here is determine when is the table wobbly enough so that I should then start to do something about it. Make sense? There's another step that happens. Yeah, I told you there would be no math, right? Once I've decided that the table is out of balance, the next step then is to run a series of possible migration simulations. Where could all these VMs possibly go? And then for each move, calculate the new current host load standard deviation with that equation. That's the ceiling operator if you were not in advanced math, to come up with an integer number. I take that, subtract it from 6, and it gives me a number from 1 to 5. That number identifies which of the priority recommendations I should automatically apply if I've set this to fully automated. Does that make sense? Now you know. So you can turn that down to fully automated and actually, get that full automation out of your DRS cluster. Is that exciting? No. Okay, well, all right. The math is just cool for me. He's saying, so if I have like end of the month or end of the quarter processing, is there anything I should do to, keep it from doing this? No. Not as a function of this. There are other ways that you can accomplish that. We'll talk about that here in a minute. So, all right. Well, if this is set the way it is, you can actually have a really big problem here. Now, this is kind of funny, especially since I'm a long hair, but number 17 is just simply being too liberal. That got more laughs last time. With your migration threshold. The reason being that migrations with lower priorities have less of an impact on balancing that table. Every migration takes time, and the DRS threads that occur every 5 minutes can consume resources. So there's this trade-off between a perfect balance and the resource cost used in getting to that perfect balance. Be aware, though, that priority 1 recommendations are mandatory. You've got a host that's going into maintenance mode, standby mode. You're violating your affinity rules. You've got where the summation of the VM reservations are actually exceeding host capacity. So all of these can have an impact on how much resources and how much activities are being involved in actually getting that table into balance. And you have to be conscious of the workloads, too. Does anybody here have, like virtualized desktops? A few of us do. One of the big concerns that can actually happen is when you go about combining your server workloads with your VDI workloads in the same cluster. And we see this happen a lot because people go and buy equipment and they go, oh, check it out. I'm going to go put the VDI workload there because, well, I have the equipment. But VDI has the types of workloads that are used by VDI are actually quite a bit different in the behaviors. There are a far greater number of concurrently running VMs. Their activities are harder to predict. There also are a higher frequency of VM power state changes. And these are, as we all know, power state changes are some of the worst things you can do to a virtual host in terms of resource use. And so VDI forces DRS to work harder and more often to balance those workloads across the cluster. The recommendation is create separate clusters. One for VDI, one for everything else, because, well, it just makes things a lot easier that way, and you can constrain all of that dynamics to a separate cluster for VDI. So I think at the end of the day, we had 19 of them here. Oh, number 19 here. The last one is overcommit. Some of us are just lazy. You know, the best systems admin is really the lazy one because we're the ones that, figure out how to automate our lives into nothingness, right? Well, you can kind of be excessively lazy when it relates to the resources you're applying to your virtual machines. Right? Back during the hypervisor wars, you remember these days, right? When VMware and Microsoft were duking it out over memory overcommit, right? And it was, hey, we can do memory overcommit, Hyper-V can't. And so many of us actually took advantage of this overcommit feature. Well, the problem with overcommit is that overcommit actually creates extra work for the hypervisor. If you have a virtual machine that it really only is using 1 gig of RAM, and you've assigned it 4 gigs of RAM, you are unnecessarily impacting the calculations that DRS is using to correctly load balance that virtual machine. Because at the hypervisor level, it needs to assume that what you have is what you're going to be using. So hopefully these 19 have given you at least some understanding about some of the different characteristics of HA and DRS that might actually cause more problems than you think. So tonight, a few things to remember after all the beers. Number one, for the love of whatever, turn on HA and DRS. I think most of us have today. You've already paid for it. It's smarter than you. Come to understand why those virtual machines move around. Make sure they've got all the right resources. And please, please, save some of those cluster resources in reserve. Thank you very much.